right, we're still in lesson 2.2 and we are writing and solving equations. So this is task 1 that we're going to do together, and then you're going to have to do task 2 and 3 on your own. So let's walk through the steps and see what to do. So it says investigate properties of equality. An equation is a mathematical statement comparing two expressions using the symbol, and you all know what the equal sign is. When you solve an equation, the solution produces a true statement when substituted for a variable in the equation. Solving an equation involves using properties of equality to write simpler equivalent equations, which all have the same solutions as the original equation. In the table, A, B, and C are real numbers. All right, so if you assume A, B, and C are just some kind of real number, the addition property says if you have A equals B, then you can add C to both sides and they're still equal. Okay? All right. In words, here we go. Adding the same number to both sides of the equation produces an equivalent equation. All right. Subtraction. Subtracting the same number from both sides of an equation also produces an equivalent equation. In symbols, A equals B, A minus C equals B minus C. They subtracted the same thing from both sides. They're still equal. Multiplication property. Multiplying both sides of an equation by the same non-zero number produces an equivalent equation. So if you have A equals B and you multiply by C, remember if you multiply by 0, it's always going to be 0. So that's why it says C cannot be 0 here. So if you multiply by any non-zero number, that's going to work. All right, division, same thing. Dividing both sides of an equation by the same non-zero number produces an equivalent equation. And again, you can't divide by 0, so they're just saying any non-zero number C. All right. Using a spreadsheet, create a table like the one shown for the equation x equals negative 1. All right, if the number in cells A2, okay, over here in A2, that's negative 3, equals negative 1, then the word yes is shown in B2. All right, so you can see that says no because negative 3 does not equal negative 1. Otherwise, the word no is shown in cell B2. So we see that that's the case here. All right, so the formula in cell B2 is if-then statement that checks the value in cell A2. Fill down the formula form cell B2 to cell B8. Which statement best describes what you observe? All right, is x a solution of x equals negative 1? All right, so negative 3 does not equal negative 1, so we put no. Negative 2 does not equal negative 1, so it's no. Negative 1 equals negative 1, so you'll see a yes right here. And then 0, 1, 2, or 3, all of those do not equal negative 1, so you'll see no's there. So it says the word yes is shown only in cell B4, so that the equation x equals negative 1 is true for all values of x. Well, it's not true for all values of x because you can see all of these x's are no except this one right here. So that one's not correct. So the word yes is shown only in B4, so the equation x equals 1 is true only for the value negative 1. So that's probably the correct answer. But let's always check all the solutions before we just move on. So the last one says the word yes is shown only in cell B4, so the equation x equals negative 1 is true for both 1 or negative 1. Well, it's not true for 1 because 1 we have no. 1 is not equal to negative 1, so the last one is not true. So if we hit check, it will show us that we got the right answer. All right. Use the multiplication property of equality to rewrite the equation x equals negative 1 as 2x equals negative 2. As you can see, if you divide both sides by 2, x still equals negative 1. So this should be an equivalent statement. Then use the new equation if-then statement for cells C2 through C8. Which statement best describes what you observe? All right, so negative 3. 2 times negative 3 is negative 6, not negative 2, so that's no. This one is no. Negative 1. Negative 1 times 2 is negative 2. Negative 2 equals negative 2, so that is yes. And you can see if you plug in 0, 0 times 2 is 0, not negative 2, so that one's a no. 1 times 2 is 2, not negative 2, so that one's a no. 2 times 2 is 4, so that one's no. And 2 times 3 is 6, so that one is no as well. All right, so it says the word yes is shown only in the fourth row, so the equations are equivalent. The word yes is shown only in the fourth row, so the equations have different solutions, but are equivalent. Well, they have the same solution. Negative 1 is the only solution, so that's not true. And then it says the word yes is shown only in the fourth row, so the equations have the same solution, but are not equivalent. Well, if they have the same solution, they're also equivalent. So the only one it could be is the first one. All right, it says use the addition property of equality to rewrite the equation 2x plus or equals negative 2 as 2x plus 3 equals 1. Then use the new equation to fill in the table. What do you observe? All right, so negative 3 times 2 is negative 6. Negative 6 plus 3 is negative 3. That does not equal 1. All right, plug in negative 2. That's negative 4. Negative 4 plus 3 is negative 1, so that one is no. Substitute negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 3 is 1. 1 is correct. And 0 times 2 is 0. 0 plus 3, 3 equals 1 is not true, so that one's a no. And then if you take 1, 1 times 2 is 2. 2 plus 3 is 5, so that one's a no. 2 times 2 is 4. 4 plus 3 is 7, so that one's no. 3 times 2 is 6. 6 plus 3 is 9, so that one is no as well. All right, as you can see, these are all the same. These are all no's, and then on row 4, these are yeses, and then all of these below are no's. So it says the word yes is shown only in the fourth row, so only one of the equations is true for x equals negative 1, and the equations are not equivalent. Well, we've already said that the equations are equivalent if they have the same value that makes them true. So we know that's not true. The word yes is shown only in the fourth row, so the equations are true for x equals 1, but are not equivalent. The word yes is shown only in the fourth row, so the equations are true for x equals 1, and they are equivalent. So they are equivalent if they have the same solution. All right, so hopefully you can see what we have done using these tables here as look to see if different equations, these are just simple equations, but looking to see if they are equivalent enough by using x values to plug in and make a table. All right, if you have any questions, please let me know.